Okay, so in this video we have another example of how to graph our trig functions here, and so we'll notice if we identify what's going on prior to graphing it, it's going to help us tremendously. So the only thing that's going on here is this b. So I look at this and I go x plus 30 is equal to 0, x is equal to negative 30. So I'm shifting left 30 degrees. So there's a couple different ways to do this. We can think of it this way. I know the shift left 30 degrees. So I know when I'm signed, I have these key points that I graph. So when theta is 90, let me erase that. 0, 90, 180, 270, and 360. These are all the key angle measurements that we're going to graph, and that's 0, 1, 0, negative 1, 0. But I'm moving left 30 degrees, so what happens is these guys are going to change to negative 30, 60, 150, 240, and 330. So these are my new angle measurements. All I did is these points are going to stay the same. Okay, so all these guys are going to stay the same, and I'm just going to shift my graph to the left 30 degrees. Okay, so I go ahead and I go back to my graph here, and I look and see how it's scaled. And it looks like I got 1, 2, 3 tick marks, right? So that means 3 tick marks, each one is 30 degrees. Okay, so I'm going to show you a different way to do this also. So that means I start at 0, negative 30. We'll call this guy 1, this guy negative 1. And the next point is 60. So I'm going to plot this guy right here. So I'm going to start labeling these points also. So this was negative 30, 0. So you can see that we're shifting these 30 units to the left. This is going to be 61. And what I'd like for you to think about is what's the distance between negative 30 and 60? Hopefully you're saying that's 90 degrees. What's the difference between 60 and 150? 90 degrees. What's the difference between 150 and 240? 90 degrees. What's the distance between 240 and 330? 90 degrees. So really, after this point, all you have to do is every 90 degrees. So you can either count 3 tick marks, 1, 2, 3. This is our 150 mark. Okay, so you can use that type of idea that you're still plotting a point every 90 degrees. That change in the degrees doesn't alter once we start at our new spot. It's still 90 degrees between each guy. And then our negative 1 is going to be at 240. And the other thing that you can think about is we're using a graph here. I'm just trying to give you different ways to use visuals to help you graph. I move back this many. So if I know all my points, right, I know 90 was here, so I need to move back just 1 tick mark, right? I was at the 180, so I'm moving back 1 tick mark. And so I can use methods like that to help me graph all different types of transformations. I'm going to go ahead and draw my smooth curve through everything, and there is sine of x plus 30. Okay, so it moved left 30 degrees. We're going to do this one now. Now this one's a reflection, right? So you see the negative, first thing we should say is, that's a reflection. So we have a sine of x plus b plus c. Let me erase that plus b, that should be a minus. Okay, just getting used to it. So a is technically 1, so there's no shift, or excuse me, no stretch up or down. But because of this negative, I know that one of the things that's going to happen is a reflection over x. There's no b because we don't have anything out here. The plus 1 is the c. If there was some sort of b change, it would be in parentheses. So I know I'm going to move up 1 unit. So here's what I'm going to do with these. Is I kind of do it in multiple steps. And I like graphing the original sine function first. So I graph the original sine function, and I just plot the points. I find this easier to do with reflections when there's a lot of different things going on. What I'll do is I will do the up one first. So I'm going to go ahead and I'm going to shift everything up 1 unit. Okay, so I'm going to do that first. And so that means I'd have a point here, a point here, a point here, a point here, and a point here. Okay? So notice what's happening, but now what happens to all these points? They reflect. So that means I'm going to take these guys and they're going to flop down on the opposite side. So this guy was at 2, it's now going to be at -2. Okay? So I find out what the height is going to be as I shift everything up, and then I do the flip with the negative. And that's how I graph something with multiple translations. I save the reflection to the very last piece. So I kind of get everything set and flip it. This guy's going to go down here. And notice the ones that are across from each other are still going to be across from each other here. Okay? And then this guy is shifted up to the 0, so when it reflects, it's going to reflect on itself. And then this guy is going to flip down to 1 right here. Okay? And we get the smooth curve. Oop, that last one should be down a little further. There we go. I'm going to draw a black line. And notice, as I put that up there, and I'm going to erase some of these. Oh, it won't let me. Put that dashed black line so we can kind of see the middle of the graph, and so we kind of, what happened here with this +1, because of the reflection, we're seeing a little bit of a shift down instead of technically a shift up, but the middle of the graph changed because of that reflection. Okay, and so what you see in blue is our new graph, and this is what I do sometimes to graph something that has multiple changes in it. And there will be a lot more examples.